All right, guys, here's another quick video. We're going to be looking at multiplying, dividing fractions today. Just an extension of adding and subtracting, but the approach is very different. Got to make sure that you're paying attention to the operation that the problem's indicating here. Obviously, this dot means multiplication, so we're going to multiply these two. Now, my rule of thumb when we multiply fractions, okay, is that we want to simplify. Then we want to multiply, okay? That is really important. If you take a look at this problem here for number one, if we multiply across the top, we multiply across the bottom, these numbers start to get big and they start to get big quickly. And then we have to worry about reducing the final answer, okay, putting it in lowest terms. But if we simplify, then multiply, we come to a result that is in lowest terms, and the math is so much easier, okay? And I'm pretty sure you guys would have seen this before. It's just a good thing to keep in mind when multiplying. We're going to simplify, then multiply. So the way that works is we look for any number up top that can be reduced with any number on the bottom. Any number. So it can be above and below. It could be diagonally. Any number. So what I'm looking for is between 11 and 2, what can be reduced with 8 and 55. So what we see here is the 11 and the 55. 11 goes into both of those numbers. So 11 goes into 11 once. So I cross out the 11 and I put a 1 there. 11 goes into 55 5 times. I cross out the 55 and put a 5 there. And then I relook at the numbers that are now there. I have a 1, a 2, an 8, and a 5. So I also notice that 2 and 8 can be reduced. 2 goes into both of those numbers. 2 goes into 2 once, 2 goes into 8 4 times. And then I look again. I have a 1, a 4, and a 5. Nothing can go into any of those numbers. So now we multiply. The rule is we multiply across the top. 1 times 1 is 1. We multiply across the bottom. 4 times 5 is 20. So 1 over 20 is our final answer. And that is in lowest terms, and we are done. Okay, so let's keep moving on to some other examples. Okay, number 2, that is also indicating multiplication. There's no raised dot there, okay, but we just have parentheses. And if there's nothing between two numbers, or three numbers in this case, we know this means multiplication of all three numbers. And again, since we're multiplying, the rule of thumb is we're going to simplify, then multiply, okay? So any numbers up top can be simplified with any numbers on the bottom. Okay, any numbers up top with any numbers on the bottom. So what I see is I have a 44 here and a 4 over here. I know 4 can go into 4 and 44. So 4 goes into 4 once, 4 goes into 44 11 times. And now we look again. Are there any numbers up top that can be reduced with any numbers on the bottom? And I notice I have a 3 up top here and a 3 on the bottom. So 3 goes into 3 once. And now I reconsider it again. I have 1, 8, and 11 up top, a 1, a 5, and a 1 on the bottom. Nothing can be simplified. So now I multiply across the top. 1 times 8 times 11 is 88. And I multiply across the bottom. 1 times 5 times 1 is 5. And that is in lowest terms. Okay, that is an improper fraction. We're not going to make it into a mixed number or a decimal. Again, that's a fair number to work with and use in all higher level math in high school. Okay, so that's the idea for multiplying. Okay, sometimes you'll see a raised dot, sometimes you'll see parentheses. Very rarely will you see an X, because an X in algebra and higher level math is usually representative of a variable. Okay, moving on, we know this familiar symbol means divide. Okay, so the way we're going to do that is we're going to actually change this. We're going to multiply by the reciprocal of 5/3. Now the reciprocal is when you switch the 3, the 5, and the 3. You switch the numerator and the denominator. So 5/3 is going to become 3/5. So we're going to rewrite this problem as 25/3. The division symbol is going to become multiplication. So I'll use a raised dot. And 5/3, the reciprocal of 5/3 is 3/5. All right, and now we're going to be multiplying these fractions together. And like what we just said up above, okay, the rule of thumb is that we are going to want to simplify, then multiply. So now I'm looking, are there any numbers up top that can reduce with any numbers on the bottom? The answer is yes. 3 goes into 3 once, 3 goes into 3 once, 5 goes into 5 once, 5 goes into 25 5 times. And now we multiply across the top. 5 times 1 is 5. 1 times 1 is 1. And what we did say from yesterday's lesson is if we can write the final answer as a whole number, that works. So 5 divided by 1 is 5, so our final answer here is 5. Okay. All right, everything's going pretty good. So that's dividing fractions. Okay. Now keep in mind, all of these are either proper or improper, right? Just a quick side note, if we had a mixed number like 2.5, right? All the operations we've been talking about can be done. We would just have to convert this mixed number into a proper or improper, in this case improper fraction. And what we would do is we take the 2, multiply it by the 2, and we would add 1. So this would be converted to 5 halves. Okay, and typically, okay, improper are much easier to work with than mixed. Okay, so keep that in mind. If you see that somewhere, that's how you would convert, and you would just do it that way. Okay. Our last problem, now this is where we get a little bit more advanced, which I like. This is called a complex fraction, and this is a fraction within a fraction. So you know this bar means division, fraction within a fraction. So we have two fractions that are being divided. So I'm sure somewhere along the way you learned to rewrite this as 8 over 9 divided by, so we're rewriting this bar as division symbol, 1/3. And then we would apply the rule that we just saw. We're going to change this to multiplication and multiply by the reciprocal. And then we're going to simplify. 3 goes into 3 once, 3 goes into 9 3 times. And then we multiply across the top. 8 times 1 is 8. 3 times 1 is 3. And that's our final answer. So that's probably how you learned it in middle school. This is probably the middle school method. Okay, what I want to show you is a little bit more of an advanced way, because these complex fractions are going to grow with complexity. All right, they're not just going to be this simple, and you might struggle doing it this way. Okay, but a much more efficient way, a quicker way of doing this is we're going to take these two fractions, 8/9 and 1/3, and we're going to find the lowest common denominator. Just like yesterday when we were adding and subtracting fractions, we're going to find the lowest common denominator between 9 and 3, which I know you guys know because I saw your work yesterday, it's 9. And what we're going to do with that LCD is we're going to multiply the top fraction by it and the bottom fraction by it. Okay, now watch how efficient and quick this is. Okay, 8/9 times 9, well here the 9s are going to cancel because 9 is really over 1, keep in mind. And we're left with 8 up top. So that's what's up top, 8. Okay, and then we take a look at the bottom, and then we could reduce that. 3 goes into 3 once, 3 goes into 9 3 times, and 1 times 3 is 3. So you can see we get the same result as down below, but this is a real efficient way of dealing with complex fractions. Sorry about that. Okay, a little bit more of an advanced method. This is effective, this will work, but this gets you to where you want to go a little bit quicker. Okay, so whenever you have complex fractions, you can multiply the top and bottom by the LCD, or you could go the longer route. That is kind of your choice, but I figured I'd show you this, and you can use this today in our worksheet. Okay, so that's multiplying, dividing fractions, including complex fractions, which might be new. At least this method here of multiplying the top and bottom by the LCD should be. And we're going to start by working through some of these practice problems, and then we'll finish up with some games at the end to see how you guys are doing. All right?